In this tutorial, we will see how to compute the tracking signal using the approach used in the Operations Management textbook by William J. Stevenson. This is not the approach used by most textbooks. If you've not done so, please view the introductory tutorial first. As was mentioned in the introductory tutorial, the tracking signal for any period is the cumulative area through that period divided by the MAD for that period. In the standard approach, the MAD is recalculated for each period. In the Stevenson approach, the first n periods is used to calculate the MAD. After that, the MAD is updated for each period using simple exponential smoothing. Once we have the MAD for period n and beyond, the tracking signal is computed starting in period n using the tracking signal formula. So, what varies with the Stevenson approach is just how the MAD is calculated. The MAD for the first n periods is calculated using the standard approach to calculating the MAD. After that, it is updated for each period using the formula shown on the slide. The tracking signal formula from the introductory tutorial is shown below that. This slide shows a set of data for periods 1 through 10 and an associated forecast. Compute the MAD for the fifth period, then update it period by period using exponential smoothing with alpha equal to 0.20. Then, compute a tracking signal for periods 5 through 10 using the initial and updated MADs. Is there bias? The slide shows a chart of the actual and forecast values. Notice that the two are very close and that the forecast in orange is sometimes above and sometimes below the actual values in blue. Therefore, we do not expect to find bias. We will begin by calculating the MAD for period 5 almost like we did in the Measures of Forecast Error tutorial. The only difference is we will add one additional column to the calculations, the cumulative error term. We will need that later for the tracking signal. For period 1, the actual of 125 minus the forecast of 127 equals -2. The absolute value is 2. For the first period only, the cumulative totals equal these values. For period 2, the actual of 130 minus the forecast of 133 equals -3. The absolute value is 3. The cumulative A minus F equals -2 plus -3 equals -5. The cumulative absolute value A minus F equals 2 plus 3 equals 5. For period 3, the actual of 141 minus the forecast of 138 equals 3. The absolute value is 3. The cumulative A minus F equals -5 plus 3 equals -2. The cumulative absolute value A minus F equals 5 plus 3 equals 8. For period 4, the actual of 142 minus the forecast of 143 equals -1. The absolute value is 1. The cumulative A minus F equals -2 plus -1 equals -3. The cumulative absolute value A minus F equals 8 plus 1 equals 9. For period 5, the actual of 150 minus the forecast of 148 equals 2. The absolute value is 2. The cumulative A minus F equals -3 plus 2 equals -1. The cumulative absolute value A minus F equals 9 plus 2 equals 11. 5 sets of actual minus forecast values will be used to compute this MAD, so we will divide by 5. The cumulative absolute error term for period 5 is 11, and 11 divided by 5 equals 2.2, so that is our initial MAD. Going forward, we will no longer need to compute the cumulative absolute error term since the MAD will be updated using simple exponential smoothing. Before computing the MADs, we will first update the totals for the remaining periods. Specifically, we will update A minus F, the absolute value of A minus F, and the cumulative A minus F. For period 6, the actual of 157 minus the forecast of 153 equals 4. The absolute value is 4. The cumulative A minus F equals -1 plus 4 equals 3. For period 7, the actual of 157 minus the forecast of 158 equals -1. The absolute value is 1. The cumulative A minus F equals 3 plus -1 equals 2. For period 8, the actual of 164 minus the forecast of 163 equals 1. The absolute value is 1. The cumulative A minus F equals 2 plus 1 equals 3. For period 9, the actual of 167 minus the forecast of 168 equals -1. The absolute value is 1. The cumulative A minus F equals 3 plus -1 equals 2. For period 10, the actual of 171 minus the forecast of 173 equals -2. The absolute value is 2. The cumulative A minus F equals 2 plus -2 equals 0. We have the totals for the remaining periods updated and the MAD for period 5. We are now ready to update the MAD for periods 6 through 10 using the formula shown on the slide. For period 6, the updated MAD equals 2.20 plus 0.20 times the quantity, the absolute value of 4 minus 2.20. That equals 2.56. For period 7, the updated MAD equals 2.56 plus 0.20 times the quantity, the absolute value of negative 1 minus 2.56. That equals 2.25. Note that the absolute value of the error term is one of the columns we have computed, so you could enter that column directly. I have not done so to remain consistent with the formula. For period 8, the updated MAD equals 2.25 plus 0.20 times the quantity, the absolute value of 1 minus 2.25. That equals 2.00. For period 9, the updated MAD equals 2.00 plus 0.20 times the quantity, the absolute value of negative 1 minus 2.00. That equals 1.80. Finally, for period 10, the updated MAD equals 1.80 plus 0.20 times the quantity, the absolute value of negative 2 minus 1.80. That equals 1.84. With all the totals and the updated MADs, calculating the tracking signal is very straightforward. For period 5, the cumulative A-F value of negative 1 divided by the MAD of 2.20 equals negative 0.455. For period 6, the cumulative A-F value of 3 divided by the MAD of 2.56 equals 1.172. For period 7, the cumulative A-F value of 2 divided by the MAD of 2.25 equals 0.889. For period 8, the cumulative A-F value of 3 divided by the MAD of 2.00 equals 1.500. For period 9, the cumulative A-F value of 2 divided by the MAD of 1.80 equals 1.111. For period 10, the cumulative A-F value of 0 divided by the MAD of 1.84 equals 0. Since none of the tracking signal values are outside of the plus or minus 4 range, there is no indication of bias. The slide shows a set of data for periods 1 through 10 and an associated forecast. Compute the MAD for the 5th period, then update it period by period using exponential smoothing with alpha equal to 0.30. Then, compute a tracking signal for periods 5 through 10 using the initial and updated MADs. Is there bias? This slide shows a chart of the actual and forecast values. While the forecast in orange is sometimes above the actuals in blue, it is mostly below the actuals, so we anticipate bias being an issue. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The first step is to compute the initial MAD for period 5. For period 2, the actual of 130 minus the forecast of 125 equals 5. For the first period of the forecast only, the cumulative total equals these values. For period 3, the actual of 141 minus the forecast of 126.8 equals 14.2. The absolute value is 14.2. The cumulative A-F equals 5 plus 14.2 equals 19.2. The cumulative absolute value A-F equals 5 plus 14.2 equals 19.2. For period 4, the actual of 142 minus the forecast of 131.96 equals 10.04. The absolute value is 10.04. The cumulative A-F equals 19.2 plus 10.04 equals 29.24. The cumulative absolute value A-F equals 19.2 plus 10.04 equals 29.24. For period 5, the actual of 150 minus the forecast of 135.76 equals 14.24. The absolute value is 14.24. The cumulative A-F equals 29.24 plus 14.24 equals 43.48. The cumulative absolute value A-F equals 29.24 plus 14.24 equals 43.48. We then compute the initial MAD as the cumulative sum of the absolute value A-F of 43.48 divided by 4. We use 4 and not 5 because there was no forecast value for period 1, and thus only 4 periods were used for the cumulative sum of the absolute value A-F. The next step is to compute the remaining totals. Notice that we no longer need the cumulative absolute value A-F values. For period 6, the actual of 157 minus the forecast of 141.14 equals 15.86. The absolute value is 15.86. The cumulative A-F equals 43.48 plus 15.86 equals 59.34. For period 7, the actual of 157 minus the forecast of 157.2 equals negative 0.2. The absolute value is 0.2. The cumulative A minus F equals 59.34 plus negative 0.2 equals 59.14. For period 8, the actual of 164 minus the forecast of 171.18 equals negative 7.18. The absolute value is 7.18. The cumulative A minus F equals 59.14 plus negative 7.18 equals 51.96. For period 9, the actual of 167 minus the forecast of 166.29 equals 0.71. The absolute value is 0.71. The cumulative A minus F equals 51.96 plus 0.71 equals 52.67. For period 10, the actual of 171 minus the forecast of 172.69 equals negative 1.69. The absolute value is 1.69. The cumulative A minus F equals 52.67 plus negative 1.69 equals 50.98. The next step is to use simple exponential smoothing to compute the MADs for periods 6 through 10. For period 6, the MAD equals 10.87 plus 0.30 times the quantity, the absolute value of 15.86 minus 10.87. That equals 12.37. For period 7, the MAD equals 12.37 plus 0.30 times the quantity, the absolute value of negative 0.20 minus 12.37. That equals 8.72. For period 8, the MAD equals 8.72 plus 0.30 times the quantity, the absolute value of negative 7.18 minus 8.72. That equals 8.26. For period 9, the MAD equals 8.26 plus 0.30 times the quantity, the absolute value of 0.71 minus 8.26. That equals 6.00. For period 10, the MAD equals 6.00 plus 0.30 times the quantity, the absolute value of negative 1.69 minus 6.00. That equals 4.71. For period 6, the cumulative A minus F value of 59.34 divided by the MAD of 12.37 equals 4.797. For period 7, the cumulative A minus F value of 59.14 divided by the MAD of 8.72 equals 6.782. For period 8, the cumulative A minus F value of 51.96 divided by the MAD of 8.26 equals 6.291. For period 9, the cumulative A minus F value of 52.67 divided by the MAD of 6.00 equals 8.778. For period 10, the cumulative A minus F value of 50.98 divided by the MAD of 4.71 equals 10.824. All of the tracking signals exceed positive 4, indicating bias.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.